In this session, we'll be talking about how we got our 3D replay technology into PlayerUnknown's Battleground. And we'll also cover our history, projects, use cases, technology, and plans for the future. So we'll be sharing several videos throughout the presentation, and we'll start off with a fan-made one that showcases our cinematic capabilities really well. So enjoy.
Take me away from home. Show me all the places I've never known. And we'll chase the night, erase all of these broken dreams and flight. And we'll
I see 2 landing late, southeast 150. I'm going to push.
Yeah, pretty cool, huh? So as you can see, you can basically, during replay, take any kind of perspective you want. You can also change the time, make it slower and faster, so there's a lot of control. And that's kind of the awesome types of videos you can create. Okay, so for some quick introductions, I'm Andrew. I'm representing MincoNet in America. And I'm here with Decker Lee, who's our guru CTO and co-founder. MincoNet created and developed a proprietary 3D replay system for gaming and streaming, and there's no impact to the game performance, and also very extreme low storage. We're here to drive player and viewer engagement, whether it's inside or outside of the game. And the company is a startup headquartered in South Korea, but we have a local office in LA, and 80% of the staff are R&D engineers from world-class companies, and we hold about 20 technology patents in the US and South Korea. And we're here to redefine the way we watch and play video games. So let's talk about PUBG. We first met the PUBG team less than a year ago in April of 2017. And at that time, PUBG was on Steam with early access and already sold about 1 million copies. And PUBG was planning on creating a replay feature, but the game far exceeded expectations, and they had like too many rapid rates of players going. And what happened was they had to scale for their servers, and we kind of already had this technology, we've been working on it for several years, and it kind of all aligned well. Not only for the technology, but the vision itself. Brendan Green understood it was essential to have these capabilities in game where we provide content creators and players with ways to create amazing and interesting videos. So with further development, we were fortunate to be able to get in time with the release out of early access, and that was about a few months ago in December 2017. We're thankful for the opportunity for PUBG, and also the many perks. We got invitations, some swag, and of course, the frying pan. So as you may know, PUBG is a battle royale genre game which allows up to 100 players to compete, and the last player standing wins. PUBG's map is massive. We're talking about an 8 by 8 kilometer and somewhat complicated landscape. So when we first worked on it, we had to simplify the map, and we kind of took out the objects that weren't needed, and we worked on that, and we integrated with that, and then the actual map. And the actual map was, of course, very hard for us. So there was a lot of hurdles. It's massive in size, and there's a lot of players. So that's sort of the know-how we kind of accumulated by doing that. And it's also developed with Unreal Engine 4 with dedicated server and client. Gameplay recording can happen in two ways. You can do the server-side game server or the game client. And when you try to replay the recordings from the server on the client, the data traffic is really high because you basically have to send all the information of the full map that you're storing on the server side. And the client needs to see that, obviously. And there's also the client-side version, which basically is you record on the client, and you're only recording your character and the surroundings and the data that exists there. And so the data size is less, and it does not have additional network traffic. PUBG decided to go with the client-side recording, and that's probably why you see that 1 kilometer radius that we'll talk about in a moment, and also showing on the map over here. So our replay file size is extremely low. We're talking about, on the client side, 1 megabyte per minute. And on the server side, we're talking about a 6 to 8 megabyte per minute for the full map. So you can imagine we're taking that data and basically re-rendering the game, and that's how we get there. And so we also, for the client side, even though it's small, we're talking about millions of sessions per day for PUBG. So that's why we had to make some constraints and limitations, and the limitations is obviously the range of replay within your character, and also the number of replays that are being stored. There are two main features in PUBG that utilize our 3D replay technology, 3D replays and death cam. 3D replay functionality allows you to record up to 1 kilometer radius around you, and you have full control of the camera, and you can jump to any player within that range you have. When the player dies, the replay files are stored from the airplane scene up to 5 seconds after your death. And from the lobby replay tab, you have the 20 slots we talked about, and you can even lock them if you wanted to. Or if you don't, then it'll expire from the oldest first. Now, let me show you a video that quickly illustrates this. Cool. So the other case for replay in PUBG is the death cam. And it shows the gameplay from the perspective of the player who killed you. And it replays for 20 seconds before and 5 seconds after death. And you know, PUBG's map is such a large map that it's common to not know how you died. So for those who played, probably use this a lot. And it helps you to get better at the game and also figuring out if somebody's cheating. And here's a clip to show you that. Just to share some stats from a month ago, it's used a lot. The 3D replay is about 9.3 million views per day, 47 million minutes per day, an average of 5 minutes per replay. The death cam, about 80% players view the death cam, 16 million minutes per day. And these are numbers from last month, and they're still growing. Good. More than anything, the content is really fun to watch. So that's why we love that our technology is out there to make this happen. So I'll talk about where it all began. So MincoNet started off renting some office space on the second floor of a factory in 2014. You see here it's some suburb with a factory there in the front. In the background you have some apartments for residential housing. And our office is like right there. And Peter, our CEO, was to handle the business, while Deckard here, the CTO of the technology. And it actually began with an idea to build a social network for games. The initial purpose is to find out what gamers needed to discuss and share. And one idea automatically was to matchmake friends through their contact list, or whether it's based on their game interest or within their vicinity. But this kind of evolved into where we are thinking about, oh, let's share some gameplay. That would be kind of cool. And that's how it all began. At that time, these ideas were based in the mobile space, so capturing video was a very big burden on the mobile device. And moreover, sharing captured videos, large data usage with high price tag associated to it. But these constraints, I believe, enabled the company to think kind of creatively about things, so that we can actually, create this technology we have today and don't have to really resort to just doing video capture. So MincoNet's focus is to provide the best replay solution for games. The approach has allowed us to focus our efforts on building technology that is compatible with widely used engines, such as Unity and Unreal. And at the time of founding, Deckard here was the only one who was on the dev team, and he had to prioritize and choose and figure out which engine to work for. And at the time, Unreal Engine 4 was available as far as the source code to use. So he, basically took the C++ first-person project template, and the team kind of built off of that. And of course, there was a lot of trial and error. There was like the frame rate synchronization, network update frequencies, and all the minute differences that made things grow in margin of error or incorrect replays. Example is like if you would record at a 60 frame per second, but let's say one frame's off, you have 61, then that just kind of blows the whole system off, because 10 seconds down the road, you'll have a different angle or the shot hit. So what he did was, okay, we got to actually capture each frame. So we started to capture each frame, but that was a massive amount of data. And so we were like, okay, what's important here? Let's look at the data and see what we really need to capture as far as something dynamic, and what's something static that we can re-render while we're replaying again. And that's sort of how it all kind of evolved. So as mentioned before, we chose Unreal 4 for the source code that was open for us. In 2016, while mobile games were showing movement into Unreal, there was still not a lot of studios who were willing to actually make that jump. So at the time, Unity was more appropriate for mobile. And in addition, UE4 introduced instant replay since version 4.6 in December 2014, while Unity did not have replay capabilities, so it was a better market for us. So although Unity did not open their engine source code, plugin development and marketing was easier through Unity and the Unity Asset Store, so we went along with that. We had experience developing the prototype, as I showed in the previous slide, in Unreal, so we were able to develop the swing replay engine for Unity fairly quickly. So I'd like to show you some demos to show you how our work has come to where we are today. We applied our 3D replay engine for Unity to various R&D projects, and the following example that I'll show you is something called Shadowgun, and it illustrates how we do live 3D replay, live VR spectating, some native ads that are embedded, and also some microtransactions. So top you're seeing the gameplay, and the bottom you're seeing some live replay going on. and you'll notice that the objects inside are replaced with some advertisement. And the advantage here is like the ads aren't intruding within the game when you're playing. It's post-production, it's after, and we can replace any objects that we want. Here's a VR where you can jump to a location and view how the ads are included in replay. You can jump to a browser and come back. Let's try and experiment, see what we can do with it. Find like an in-game item example. Cool. So the next thing we have is again another illustration with the same live 3D replay, live VR spectating, native ads, and microtransactions. But moreover, it demonstrates live streaming in 360 videos. So when it's loading on mobile, on Unity, you can choose which perspective you're going to save the video file in. At the top, you have the gameplay with the VR spectating mode on the bottom. And our intentions here is to engage the players outside of the game. So, you have platforms such as YouTube using our technology. Can also be utilized for various esports applications too. Item example there. This is an example of a 360 where you supposedly click on a vehicle and you can see how the vehicle interior looks like. Yeah. Okay, cool. So let me try to get this working. It's an actual 360 video example that I like to show. So yeah, you have the gameplay and you're spectating things in 360. So you have all these different angles you can watch the game being played in. Take any angle. And if you were to disable 360, you would see something like this. Okay, let me just pause that. Let me close that. There we go. Okay, thank you. Okay, got through that. My cursor here. Okay, good. The third use case is a UE4 version, and it's an app called Tank Up, and it shows different camera angles from the enemy's perspective in live. And where there's multiple enemies, the camera will automatically set to whomever the heaviest attack is.
Handy. Gotcha. That's smart. All right.
So you have the gameplay on the left, and the right side, you're taking the
Smart.
perspectives, again, as I mentioned, depending on like who's attacking you.
That's smart.
So you can see this is being done automatically, and you can see some use cases of how it can be applied to games today. Final UFO boss.
Come and get it, you
Okay, so there's of course other use cases. We're fortunate that we have been contacted by many studios, and we've been combining forces and coming up with various use cases. Some examples are post-match highlights, having collections of great moments, integrating this technology directly into the game mechanics, so you have like the whole replay time thing going on. Also, there's a use case for cutscenes. We're using it for cinematics because they wanted to match the gameplay in some way and use this as sampling that. And of course, advertising. There's also a lot of microtransaction ideas that have emerged, using replay for use of range, length, expiration, and a lot of other cases. So talk about technology now. At a high level, our technology is divided up into client-side and server-side components, and depending on the game's need, we skew towards either side. There's the client component that has the replay subsystem as a game engine plugin for a game engine. And there's a server component that has a replay server that stores and delivers the captured gameplay on demand or in streaming. And this is done in second chunks. So for instance, if you have like a 3-second chunk, then it gets delayed and you're actually stitching them together. So you can go back any 3 seconds and beyond, and it somewhat seems like it's streaming. And further optimization and tuning is of course necessary for each game, so that's why we do some services and making sure it plugs in with our APIs correctly. We also have 3 areas in mind for our platform. We have the game engines, whether it's Unreal, Unity, Lumberyard, and other engines that are coming. And the replay plugin side, which has a slew of APIs that are accompanying with it. And on the application side, there's various applications that we're working on, whether it's Creator's Kit for editing, AI, data analytics, because we're sitting on so much data we can repurpose, VR, and game features that we just talked about. And these are all in the works. For the server side, we separate the recording and playback servers to balance the workload. In the case of many to watch at the same time, such as for esports viewing, we can cache and load balance and distribute it to make that happen. And we support HTTP streamer REST APIs for replay servers. So what's next? So there's a bunch of creative tools that we want to empower the creative community to build more things and awesome videos. So that's why we're focusing on creating those tools directly in game. We also have a whole server-side streaming replay for live esports that we're working on. There's of course big data and artificial AI that we can enable and make things automated. Native ads, as I showed, you can replace objects within during replay and not intrude in the gameplay. And of course, there's players who just want to do good on the game, so that's why the replays are helpful, so they can actually go and review and see how they can get better at the game. Some ideas is like we can add in some stats of players if we connect to the player database, so that we can show that while they're doing esports and be like, oh, that's cool, I know that guy, and I know more about him now, and I know how I got killed, so then I can do better next time. Last but not least, we have the whole anti-cheating solution, where this has emerged a lot in the death cam, and it's actually when you report in PUBG, it sends like a file so then they can review it to see if whatever you submitted is valid or not. And that's been an emerging market because it takes a lot of operation for a studio or developer to go through all those stuff, and if there's a way to auto flag that, then that's a way we can help out. So our future is really bright, and we're ready to write a new chapter. And the good thing, in a new office and not a factory, and it's located in Gangnam, so we're trying to do it Gangnam style, man. So we believe that games are the next form of watchable entertainment, and we really strongly believe that we have the power to shape the future of this gaming industry. Creators are able to capture cinematic videos that are not apparent during gameplay and share on platforms using our technology. And our tech is driving this engagement even outside of the game. Okay, before we finish off for the questions, we'd like to share another video that showcases how we empower gamers to become creators.
It's not the end of the world, quite nice at this point, looking for armor still, obviously. That's what you want the basics, right? You want the level 1 helmet. At least then you can be relatively safe in that first bit of loot exchange. But you want to head down with the level 2s to level 3 really at this point, especially at this level. You need that sustainability. You want to use that first circle again.
And that was it. I hope it was helpful. And yeah, we'll now take any questions on the later half of this session. And if anything technical arises, I'll just ask my friend here, Deckard. And what I'll do is I'll translate if there's anything that we need to translate.
Yeah, thanks for the talk. I just had a question about what data you're actually storing in Battlegrounds. Like, well, your data footprint's very small, so I was just wondering what's in every frame.
Okay. Yeah, so an example is you have like the characters, you have the vehicles, you have things that are movable that you have to track during the different frames, and those we are storing. But the data as far as things that are situated, like the buildings and the landscape, those we're not storing.
Sure, but specifically in the characters, like how do you save their animation?
Oh, okay. Yeah, so it's a binary file that we're storing with the game. And if I understand you correctly, there's a lot we're storing. We're storing like tens of thousands of data points. But when it comes to the client side, since we have a 1 kilometer radius of restriction, we can reduce the amount that we're storing that way. And as opposed to that, on the server side, we're storing everything, so it's on the server. But maybe you can elaborate a little more, and I can. Sure.
Well, do you store like the bones, for example?
The bones?
Like the bone positions of the
oh, okay. Let me ask. Okay. Yeah. So Deckard says we don't store all those particular details, but we store the animation side of things, whatever is moving that can be observed.
Okay,
Yeah.
cool. One last different
Yeah,
question.
sure, please.
At the start, you said there was no cost. So, do you mean that it's very low cost, or
Oh,
like-
cost as in the performance cost?
the performance cost in the game engine? Because I see you have a record engine in the game engine.
Yes.
So, I'm guessing there must be some cost.
Yeah,
right?
sure.
그래서 거기 얼만큼의 노화가 있는지 서버 사이드에서 이렇게 테스트가 하는데 33프레임에서 32프레임을 줬어요. 카드에서 한 60프레임에서 58프레임을 줬어요. 그 정도 차이가 그 정도 거리를 줍니다. 50프레임에서 50프레임. 그러니까 게임 플레이한테 60프레임인데 에코 들어가게 되면 59프레임을 줬어요.
So you're saying, like, if you're recording at a 60 frame per second, it could possibly be recorded at 58. So there is like a reduction. Yeah.
Cool. Great work, guys. Thank you very
Great.
much.
Thank you. Good question. Yes.
How simple is it to integrate your solution into the game? What does the developer need to do?
So right now, it does need some of our help and support because we're in a stage where we've done it with PUBG, and we're reducing the amount of integration needed, of course, because we've already done it. And we're going to get to a plug-in state in about a year, early next year. So at that time, it'll be way more simpler. But right now, as currently, there is some work. But we do have the server-side APIs, and we have all that. It's really more it's like each game's so different. So what we've realized is, you can plug this in and use it if your use case is really simple. But if you start having particular use cases and your map is huge and a lot of people, then that's where we have to actually work together to figure out how we're going to make it optimized properly.
Okay.
Okay.
Thank you.
Thank you.
Hi. So if you're storing all of just the raw data, does that mean that on the client side, the user can display it at any quality? Like, could they choose, like maybe they can only render the game at a low quality, but can they view their replay at a really high quality?
Yeah. So I think I know the answer, but let me verify.
그 이제 레코딩을 할 때 다시 재생할 때 레코딩을 저음이라고 했는데 재생할 때 하이 퀄리티로 할 수 있는 데이터니까. 그렇죠.
Yeah. So right. Yeah. So since we're recording the data and we're replaying it, you can replay it and set any type of resolution you want. So it's not like it's like a video file. If you record it, you're kind of stuck with that, right? No.
모바일에서 레코딩해서 PC에서 재생할 수도 있는 거죠.
Oh, okay. Oh, good. So you got a good point. So you can even record on the mobile and play on the PC at a higher resolution if you wanted to, because it's really you're replaying the engine again.
And then just a quick follow-up. So you were talking a little bit about how you could stream with it as well. Have you
Yes.
guys done any work with streamers for, like for instance, StarCraft players play on like super low quality, but nobody really likes watching super low quality. So have
Yeah.
you worked with them for letting them like send out their encoded
Yeah.
high quality, but so that they can still play on low quality?
Oh yeah. There's definitely a big demand that we're getting for the whole esports and all that stuff. With again, like because we're replaying, you can have multiple views at the same time without hitting performance. So definitely that's an area that we're working on. We don't have one yet in the public, but there are applications, things that we're working on.
Thank you.
Yeah. Thank you. All right. Yeah.
Hi.
Hi.
So you said you had two solutions, one client side and one server side. So can you tell us why you choose to use the client side approach for PUBG and not the server side?
Yeah, so that was a decision, as I might have mentioned, based on cost, the network costs. Again, like PUBG probably didn't realize it would be such a success. So when we had so much data coming through, it has to be stored somewhere. So it came down to a decision that we should keep it on the client side.
Okay, so it was a cost saving.
Yeah,
decision.
cost. Yeah, the network cost for sure.
Okay. Thank you.
Yeah, thank you. Oh,
Okay, thanks for your talk and congratulations on your new buildings.
thank you. Thank you very
Yeah,
much.
and my question is, I'm from China, and I wanted to know if our game wanted to apply the 3D replay technology to our games, how would it happen? I mean, how we collaborate with each other, and how long will it take? Will you
Yeah.
send your technical guys to our company?
Oh yeah. So yeah, we have. It depends on the game again, like the complexity of the game, the use cases. If you're talking about something simple, we've reduced it down to several months now, and we also have on-site support in the beginning for now until we're going to get to that plugin state. And yeah, maybe after we can talk about it if you're interested and see what we can do about it.
Okay, thank you.
Yeah, thank you.
Hi, I think you mentioned this in one of the earlier slides, but UE4 has had built-in support for replays for multiple versions now.
Yeah.
I'm just curious if your solution is kind of an independent implementation of that, or does it build on top of the existing support in UE4?
Yeah, we've enhanced what UE has, as I showed you exactly the prototype. We've kind of extended out in a way where like we focused on the kind of game need, and we've been developing in that arena, and so we've optimized. So our specialty is that we optimize based on a very wide map, along with having multiple players. So it's built on top of it, of course, like how almost every asset store has stuff that are built on top of the engines. But we focus on this, and the particular difference is that we not only work on Unreal, we work on other engines too. We're agnostic. So for developers on a different platform, you have another selection to make for us.
Okay, thanks.
Yeah, thank you. All right. Any more? No? Good. All right. Well, thank you very much, and I hope you enjoy the rest of GDC.